I'm so excited for this video. I already started writing the video down, okay? But I'm gonna wait for you. We're gonna differentiate this function. This is the video on something called logarithmic differentiation, and it's magical, okay? This is the differentiation that will just make all your problems go away, okay? If I were to start some kind of business that's a pyramid scheme, this is what I would do because everyone wants this, all right? So this looks terrible. To differentiate this before this section, we would lose our minds, okay? But if this were a logarithm, it'd be much easier to differentiate. If we had the logarithm, right, we could just split all these up, right? Add all these ones on the top together, subtract the one on the bottom. The square root just comes out in front as a 1/2. The logarithm of this is nice. So let's make it one. Right here, I've immediately made all your problems go away. Because now the right-hand side's super easy. The problem is, I have also given you a new problem. I've lied to you. F of x is equal to the right-hand side. So if we're going to take the logarithm of the right-hand side, we also have to take the logarithm of the left-hand side. So I can take the logarithm of both sides, no problem. It's a one-to-one function. Just like I can divide both sides by 2, multiply both sides by 2. Now let's rewrite the left-hand side. Let's write it as the natural log of y. A lot of times we use f of x and y interchangeably. All right. And let's rewrite the right-hand side too. The right-hand side we're going to rewrite a lot, because we can simplify the right-hand side by a ton. It'll be the natural log of the first guy, plus the natural log of the second guy, plus the natural log of the third girl, minus the natural log of the denominator. And we can simplify it a little bit more, right? Left-hand side stays the same. Right-hand side mostly stays the same. First one is good. Second one is good. Third one is also good. Fourth one, remember square root, that's an exponent of 1/2, and the exponent can come out in front. 1/2 natural log of 4x plus 1. And this doesn't look super clear, but taking the derivative is going to be a lot nicer. But be very careful. When we take the derivative, we also take the derivative of both sides. I've changed the left-hand side. We can't just say left-hand side, take the derivative, it's y prime. Left-hand side, how are we going to take the derivative? We're going to take d dx of both sides. So we need to find what is d dx of the left-hand side. And we need to find d dx. We have to take the derivative of both sides. This is implicit differentiation. Remember, implicit differentiation is when we take the derivative of both sides of an equation where one of them is not solved for the variable. We have to use the chain rule on the left-hand side. So it gets better though. Look, the derivative of the left-hand side with respect to x. Well, it's the natural log. Derivative of natural log is 1 over the inside. But the problem is, we're taking the derivative with respect to x, not with respect to y. So by the chain rule, remember, that says multiply by the derivative of y, which is dy dx, or y prime, or f prime of x, however you want to write it. And then the derivative of the right-hand side, well, we're used to this by now. Derivative of the natural log is 1 over the inside, times the derivative of the inside. The derivative of the inside here is just 1. Next, derivative of the natural log is 1 over the inside, times the derivative of the inside, which is 2. Plus, all right, I'm getting sick of this. It's all the same, right? Derivative of this natural log is 1 over the inside, times the derivative of the inside. This one over here is 1/2 times derivative of natural log 1 over the inside plus the derivative of the inside. And I'm probably not convincing a lot of people because this is still a lot of writing. But I guarantee, even though it's a lot of writing, it's a heck of a lot better than trying to differentiate the first thing. I can't even show you what differentiating the first thing would be like without logarithmic differentiation, without making myself melt into a puddle on my carpet. And I don't want to do that. So we're getting close. Okay, let's keep working on the right-hand side. Left-hand side will keep tight, sit tight for a bit. All right, first thing, oh, that's already simplified. 1 over x plus 1. Second thing, let's put the 2 up top. And remember, they can't cancel. You can only cancel fractions if you have common factors. The top has a factor of 2. The bottom doesn't have a factor of 2, though. We can't factor 2 out from everything over here. Okay. So this one simplifies to 3 over 3x plus 1. This one, we have 4 divided by 2. Okay. So that's just going to be 4 divided by 2, right? That cancels. This becomes a 2. This cancels. We're going to be left with minus 2 over 4x plus 1. We're almost done. The right-hand side is fully simplified. We could combine the fractions, but this is a pretty good way to have it. But the problem is we're trying to find y prime. So we need to solve for dy dx. Right? We need to solve for dy dx. So to get it by itself, we're going to multiply both sides by y. So this side gets multiplied by y. They're going to cancel. And this side gets multiplied by y as well. So we're going to get dy dx is equal to 1 over x plus 1 plus 2 over 2x plus 1 plus 3 over 3x plus 1 minus 2 over 4x plus 1 multiplied by y. And this right here is a magical step. Well, there's been so many magical steps. This is just magic, okay? We could rename this video title to Jason and one, I don't know, it sounds weird. So what was y? Right, we're multiplying everything by y, but what was y? Y was all of this. Remember? Right, so we're just going to multiply it by all of that, which is x plus 1 times 2x plus 1 times 3x plus 1, all divided by the square root of 4x plus 1, right? Remember, the very original of the problem, y was equal to all of that. So we're just replacing the y. We want our answer to only have x's in it, okay? So that's where that came from. And we have our derivative. And it's a little messy, but it was relatively painless. Right? We took us half a page, but we could do it. All right? If you do this problem without logarithmic differentiation, you are going to be really in a pickle. But maybe I haven't convinced you. Maybe I haven't convinced you. As a side note, there's actually a really cool way of simplifying this. If you distribute this, it simplifies to something really nice, but we don't need to. All right. So let's do example 6. No, let's just do part B. F of x equals x to the x power. This is a really funky function. I think somebody was asking me about the derivative of this function the other day too. We can't use the power rule, right? Power rule is only x to a constant. Can't use the power rule here. We can't use the fact about exponentials because that's a constant to x. We can't use anything. We cannot differentiate this with anything that we've talked about for this whole semester. We don't know how to differentiate it. X to the x is a super wonky function. You know what? It's so wonky. I'm going to show you what it looks like. All right. This function's super bizarre. Y equals x to the x power. Look at that. So it's super weird for negative values. It's not continuous at all, just random dots. And for positive values, it does this super kind of a strange weirdness. It's a bizarre function. So the derivative is not even going to exist over here. These things don't have derivatives. We're not going to worry about those. But for the positives, we can worry about the slope. All right, so this is a bizarre function. Derivative is not easy. But what we can do is we can find the derivative with logarithmic differentiation. Let's call f of x equal to y. We have y is equal to x to the xth. All right. So take the log of both sides. The natural log of y is equal to the natural log of x to the x. And we'll simplify. How does the right-hand side simplify? Properties of exponents say the x comes out in front. This becomes x times the natural log of x. Also, as a side note, no, I won't spoil it for you. Now, instead of something we can't take the derivative of at all, we can take the derivative of this. And in fact, it's a pretty easy derivative, all things considered. So let's ddx both sides, okay? If we take the derivative of both sides with respect to x, on the left-hand side, the derivative of natural log is 1 over the inside. But we have to multiply by the derivative of the inside. And the derivative of y with respect to x is dy dx. Every time you do logarithmic differentiation, this is going to be your left-hand side. Okay? And the derivative of the right-hand side, we have to use the product rule. Okay? So the derivative of the first function is 1 times the second function, plus the first function, which is x, times the derivative of the second function. Derivative of natural log is 1 over x. Now this is really nice. Let's multiply both sides by y. dy dx is going to be y times the simplified right-hand side. 1 times ln x, that's just ln x. X times 1 over x, that's 1. This is super nice. Look at this. We couldn't take the derivative at all. And now we got something really nice. Let's put everything in terms of x's, right? What was y? Y was x to the x power. So it's y times all of this, ln x plus 1. So it looks kind of funky. But we use logarithmic differentiation to solve something we'd never, ever be able to solve some other way. So remember the graph. I said it's a super weird graph, and it is a super weird graph. And I said, notice that there's only a slope for positive numbers. All right? Right? It's not continuous over here. We got super bizarre, weirdo stuff going on over on the left. All right? And why we get super bizarre stuff is a long story that we don't have time for. We'll look at our derivative. We should only have a slope for positive numbers. Well, what is our derivative? Our derivative has a natural log. And remember, the domain of a natural log is only positive numbers anyway. So you can kind of see in the equation for the derivative that, yeah, it's only going to have a derivative for positive numbers. Okay? So this is a tough section. Let me know if you have questions. I will be available. I won't be I won't be here this weekend, but I will be available if you contact me. I'll get back to you whenever I have a free moment. Okay? And I will see you on Monday. We're going to start meeting Monday via Zoom. All right? I'll send out another reminder as we get closer to that. Good luck.